On this video, we're going to talk about section 1.1, which is functions and models. So the first thing that I want to do is actually define what a function is. So I'm looking in your ebook here, and guys, I do strongly encourage you read your ebook, look over all the stuff that comes in it. It's a great tool for you to have, on top of watching these videos. Okay, so let's skip over to page 11 here. Here is our definition of a function. A function is a rule or correspondence that assigns to each element of one set called the domain exactly one element of a second set called the range. So the function may be defined as a set of ordered pairs, a table, a graph, an equation, or a verbal description. We are going to see all of these examples used where we're asked to figure out if it's a function or not. Now, one of the things that I do want to point out here, they use the word, let me pull my pen up. They use the word domain, and then they use the word range. If you've done any type of graphing, you're probably familiar with the idea of what domain and range is, but there are other ways of stating the domain and range. So I'm going to write those out for you. The domain may also be referred to as the x value, or more frequently in this particular section, the independent variable. So if you see domain, you see x value, you see independent variable, all of those things mean the same thing. You're talking about the first element of your function. Range can also be defined as the y value or the dependent variable. So all of that terminology means the same thing. So I just want you to realize that, if they ask for one or the other, it's all the same thing. Okay, so mathematically speaking, the way that we write a function is this. We say f of x is equal to y. So what this means is, let me kind of break this apart here. This f is just your function name. So it doesn't have to be f, it could be g, it could be h, it could be q, whatever. That's just the name of your function. And we do this so that if we've got multiple functions, we know which function we're referring to. So f is your function. This x here is your input. And this y is considered to be your output. So actually, we could go up here and add that to this list too. We could say this is your input, and your range is considered to be your output. So all of that means the same thing. Basically, what you're going to be asking yourself throughout this whole entire section, and what your book's going to be asking you is y a function of x? So that's kind of the verbiage that we're going to be using. So is y a function of x? Now, I know all this sounds confusing. Let me see if I can make it a little bit easier. So a simple way of saying whether a set of ordered pairs, a table, a graph, an equation, or a vertical description is a function is to ask yourself whether the x values or domain or input or independent variables, whatever, repeats itself. So if it does not, it is a function. So if your x values do not repeat themselves, it is a function. Now, one of the things I want to say here is it doesn't matter if your range values or your y values repeat themselves. It's the domain. It's the x values that I'm concerned with. So whatever they consider to be the domain is what is going to tell me whether something is a function or not. So I know lots of definitions here, lots of things going on. It's really fairly straightforward. So let's go look at, I'm going to look at number 1 on page 19. So let me clear this out. So number 1, it's a table A gives y as a function of x. Again, that's that verbiage that they're going to be using throughout this section. With y equals f of x, that's just the definition of the function on this particular one. So they ask us, is 5 an input or an output of this function? So we are using table A, so I'm going to be using this one. So is -5 an input or an output of this function? If you will notice, -5, which is right here, is in our X row. So that's considered to be an input. It's an X value, it's an input, it's part of the domain, all that good stuff. So in part A, it's an input. So in part B, is f of -5 an input or an output of this function? Well, that one is completely dependent on the way they write it. Remember, I give you the definition that f of x is equal to y. So f of x, if you're taking the function value of x, that's going to give you your y value. So when they write it f of -5, that's equivalent to your y value. So what that means is that's actually our output. So it's just a really funky way of writing that this is going to be our output value. On part C, they ask us to just state the domain and the range of this function. So the domain, I think I'm going to come, we'll try to write it right here. The domain is simply saying, okay, well, what's all of my x values? What x values are included in this particular table? So I'm going to write the domain like this. Because it's a set of numbers, right? The domain is going to be all of these numbers up here. I'm going to use, and that is a really terrible looking one. I'm going to use a brace to signify that I've got a set of numbers here. If you were talking about the domain or range of a graph, we'd actually use interval notation to signify that. But for when we've just got a table of numbers, this is what we got. We don't have an infinite set of numbers here. We've got -9, -5, -7, 6, 12, 17, 20 as the x values. I use my braces here to signify that set. So I'm going to have my domain be -9, -5, -7, 6, 12, 17, and 20. Yay. So there's our domain. So if that's our domain, my range is going to be the y values. And of course, my y values are these numbers down here. So my range is going to be, here's my little braces again, 5, 6, 7, 4, 9, 9, and 10. Now, one of the things that I do want to point out here, they told us, no, excuse me, we'll cover that in part D here. So part D, explain why this relationship describes y as a function of x. So they told us that this thing was going to be a function up here when they said y is a function of x. But let's talk about why it is. So the correct mathematical terminology for why it is a function is that each input only gives one output. Now, again, for some odd reason, that terminology has always been confusing to me. It just, I don't know, it doesn't really state to me what that means. So the way that I think about it is if you look at your x values, do we have any x values repeating in table A? And the answer is no, I don't have any x values that are repeating. And guys, I'm going to show you why that makes a function here when we see a graphical representation of this. It's really cool. Now, I do want to point out you do have some y values that repeat, right? You've got the same 9s in the y values there, and that's okay. Your y values can repeat as many times as they want. That does not affect whether it's a function or not. It's only the x values that I'm concerned with. All right, let's do another example. I want to look at, let's go to number 14. So number 14, does the table below define y as a function of x? If so, give the domain and range. If not, state why not. So one of the things I do want to point out here, this terminology is very important. Y as a function of x. What if they said x as a function of y? If they were to write it that way, we'd actually flip it. If they had x as a function of y, our y values become the domain or the input values, and our x values would become the range or the output values. So it is very important how they state this. Now, for the most part, your book is really good about keeping it y as a function of x. Now, sometimes they will try to confuse you, but for the most part, it sticks this way. So y is a function of x. So they tell me x is the input values, the domain values, y is the range values, the output values. So looking at this to figure out if it's going to be a function of x, I need to look at these values. So I'm looking in there to see if anything repeats. So do we have any repeating numbers? And the answer is yes. We actually repeat the 2, which is not good with the x values. So this thing is not a function. And the reason for that is because the input 2 has 2 different outputs. That's the mathematical terminology behind it. So the input value of 2 has 2 different outputs. Or in other words, your x values are going to repeat. Now, I do want to do something while I've got this table pulled up here. I'm going to add an extra part to number 14. And I'm going to ask you to find g of -3. And I also want you to find g of 3. So this is just an extra part I'm throwing in here because I want to show you how the functions actually work. So when I ask you to find g of -3, I'm stating that I'm calling this particular function that represents this table g. I can call it anything. Typically it's f. I went with g just because, you know, I can, and it's late and I wanted to get all crazy. But if I'm asking you to find g of -3, please notice that the -3 has taken the spot of the x value. So what I'm telling you is that if I'm telling you that x is -3, what I want to do is I want to figure out what's the y value associated with -3. Let me do some erasing here. Let's get rid of this. So if g is -3, I'm giving you this. I want to know what y value corresponds to that. And of course, the y value that corresponds to -3 is 12. So g of -3 is 12. So when they write a statement like this, they're basically saying, okay, well, if you've got a point of -3, what's the y value that goes with it? And of course, it's 12 with this one. Same thing with g of 3. So if I look at g of 3, here's g of 3. What's the y value associated with g of 3? Well, that would be 16. So g of 3 is 16. So I just wanted to go ahead and show you that. That's going to be a very common question that's asked on your homework. So there you go. Let's go on and look at, oh man, we got to do number 8. Number 8 is cool. So number 8, for each of the functions y equals f of x described below, find f of -1. So they're giving me a graph here. We've got a table, and then we've got this lovely equation right here. So let's work with the graph first. So f of -1. Now the problem that we just did, remember I said that whatever's in that parentheses there, that's telling you what your x value is. So you want to figure out what your y value is that is associated with that particular problem or that particular x value. So looking at the graph, so this will be part A. F of -1. So here's -1, right? So I'm just going to follow this thing up until I hit my graph. And the reason I'm going up is because my graph goes up. So my y value is going to be whatever this point is here. So my point's -1 comma what? That's what I'm after. This graph goes up to 8.2. So I'm going to assume that this is going up by ones. So let's see here. We got 1, 2, 3, 4, 5. 5? Yeah. So f of -1 is 5. So -1 comma 5 is the point that we're looking at. This is the x value. This is the y value. I do think that the graphs are probably the most confusing when it comes to finding functional values. It's hard to break that point apart to see it as an x and a y value. The tables are a lot easier, so let's do part B. So part B, same question. I want to figure out what f of negative 1 is. So f of negative 1, here's my x value of negative 1. What's the associated y value? And the associated y value is going to be negative 8. So f of negative 1 is negative 8. Now part C, they give me the function f of x equals x squared plus 3x plus 8, and they're asking me to find, again, f of negative 1. I want to show you something. So we've got f of x equals x squared plus 3x plus 8. See how negative 1 is taking the place of x here, right? So if negative 1 is taking the place of x here, guess where negative 1 is also going to take the place of? And that would be this x here and here. So f of negative 1 is going to be equal to negative 1 squared plus 3 times negative 1 plus 8. Guys, do be careful with your parentheses. They are important. You do need to include them, especially when you have exponents, because a negative 1 squared is different than parentheses around a negative 1 squared. And if you don't believe me, punch it on your calculator and see what it gives you. So negative 1 in parentheses squared is going to be a positive 1. 3 times negative 1 is negative 3 plus 8. So 1 minus 3 is negative 2. Negative 2 plus 8 is going to give me 6. So f of negative 1 is equal to 6. All right. We're moving right along here. Let me clear this out. Okay. So graphically speaking, you can tell whether an equation is a function by looking at whether it passes the vertical line test. Now the vertical line test, there's a box about it in your book. Let me see if I can find it here. There we go. So vertical line test. A set of points in a coordinate plane is the graph of a function if and only if no vertical line intersects the graph in more than one point. I love the vertical line test. It is one of the nicest things you're going to do in this class. Basically, what happens is if they give you a graph, to check it, you just kind of slap a vertical line on it. If it only hits in one spot, it's a function. If it hits in more than one spot, it's not a function. So let's look at number 15 here. Number 15, I've got a circle, right? If I was to place a vertical line anywhere on this circle, let's say like right here, how many times did my vertical line hit this graph? There's 1, there's 2. That automatically means that number 15 is not a function. And here's the reason why it's not a function. Let's say, for instance, this point I went through is, I don't know. Let's say it's like negative 1.3. It's negative 1.3 comma 1. Here we've got negative 1.3. 1.3, not comma. Negative 1.3 comma 2. So that's the 2 points I have highlighted here. Now remember, we said to be a function, your x values cannot repeat. And what do you have repeating here? Well, you've got the same x value. That's why the vertical line test tells you whether something's a function or not. If you cross a graph twice, you've got the same x value, so it's not a function. Really cool how this stuff all works together. Number 16. Let's see, I'm going to draw my vertical line here. Okay, I'm only hitting the graph in one spot. What if I try here? I only hit it in one spot, right? What if I try here? I only hit it in one spot. So what that means to me is that this thing is a function. We don't have any x values that are going to be repeating. Cool. So that's not bad at all. I love the vertical line test. This class would be awesome if everything in this class was solely vertical line tests. But alas, it's not. So let's go look at something else. I think we should do some word problems because we love word problems. Those are fun. Before we jump into word problems, I do want to kind of define what mathematical modeling is. The process of translating real-world information into a mathematical form so that it can be applied and then interpreted in the real-world setting is called modeling. A mathematical model is a functional relationship, usually in the form of an equation, that includes not only the function rule, but also descriptions of all involved variables and their units of measure. So what we're going to be doing now is we're going to be looking at either equations or tables or stuff that's going to describe real world occurrences. I want to look at number 41. Number 41, where are you? There you are. Let me skip back a page here. I want to see what the directions say. So the directions for number 41 say, determine whether the given relationship defines a function. If so, identify the independent and dependent variable and why the relationship is a function. Again, when we're identifying why the relationship is a function, if it ends up being a function, I do want to talk about how, we don't have inputs repeating and all that. Number 41. The following table represents the percent P of Americans who are obese. That is, they have a body mass index of greater than or equal to 30 for selected years Y, starting with 2000 and projected to 2030. Now, this is a very common occurrence in mathematics. Instead of having an X and a Y, they changed the variables up on us. So they're telling us that the percent is going to be represented by P. So this is my P value. And the years are going to be represented by Y. So yeah, it's kind of backwards where we've been seeing our Y. Typically our Y is on the bottom. That's okay. It's just an arbitrary letter. They called it what they wanted to call it. So again, our inputs are going to be the years. Our outputs are going to be the percentages. So we want to figure out, is this thing a function? And if I look at what's considered my input values, these are my input values, correct? And do we have any of those years that are identical? No. So we've all got different years. So what that means to me that yes, it is a function. So it's a function. Now I'm going to be very careful with how I word it. And guys, one of the reasons that I'm making such a big deal with the wording is because you are doing your homework on my math lab or whatever it is, my lab math, whatever it is they're calling it now. The wording is very important. I think they do like multiple choice where you click which wording makes or goes with the problem. And if you don't click the right wording, they count it wrong. So please, please, please be very careful how you look at the wording. So my wording is going to be, it is a function because there is 1% P for each year Y. So yes, our inputs don't repeat. Mathematically speaking, the Y is one, or there is one Y or 1% P for each year Y. I got all tongue-tied. So because it is a function, let's talk about what our independent and dependent variables are. The independent variables, of course, is going to be the Y. And our dependent variable will be the P. All right, let's go on and look at, let's do number 50. Let me clear this out. Number 50. Ooh, look at all the parts to number 50. Okay. A couple can afford $800 per month to purchase a home. As indicated in the table, if they can get an interest rate of 7.5%, the number of years T that it will take to pay off the mortgage is a function of the dollar amount A of the mortgage for the home they purchase. And we've got all this information. So if the couple wishes to finance $103,000, for how long must they make payments? And we're going to write this correspondence in the form of T equals F of A. Now, this is very important here. The number of years T that it will take to pay off the mortgage is a function of the dollar amount A of the mortgage for the home they purchased. Now, if you'll remember, I said Y is a function of X. That's how they state it. So the Y is the output, the X is the input. So what they're telling me here is that T is my output. And my input is going to be the A value. So as long as you remember that wording, you can figure out what your input and output are or is very easily. So if the couple wishes to finance $103,000, so that's right here, how long will they have to make payments? So they would have to make payments for 20 years. Now, I wish I could just sit here and say, oh, it's just 20, move on. But they do want it in the function form. So in part A, they tell me I want T equals F of A. So if I write it in function form, my T was 20. And my A was 103,000. So that's actually how they want the answer wrote. Okay, part B. What is F of 120,000? And write a sentence that explains its meaning. So F of 120,000, notice the 120,000 is taking the place of A. So here's my A value, 120,000. So F of 120,000 would be equal to 30. So what does that mean? It means that it will take 30 years. Man, my handwriting's getting bad on this thing. It's going to take 30 years to pay off $120,000. Now, being up in Boone, you know that it's almost impossible to find a house for $120,000. Boone is one of those places that the real estate has really taken off. Part C, what is F of 3 times 40,000? One of the things I want to point out here, do you see how the 3 times 40,000 is in parentheses? That means that I'm going to follow order of operations. So I'm actually going to figure out what 3 times 40,000 is. So 3 times 40,000, of course, is 120,000. This is asking the very same thing that the last question asked. So F of $120,000 is going to be 30. They're just trying to get us to realize that they can actually write these questions however they want. Okay, part D. What value of A makes F of A equal 5 true? So remember, this is my input, right? So the 5 is representative of my output. So I'm going to go look in the years column there. So here's 5. What's my A value going to be? Well, A would have to be equal to 40,000. Okay. And finally, part E. So part E says, does F of 3 times 40,000 equal 3 times F of 40,000? Now, we already know that F of 3 times 40,000, which ended up being F of 120,000, is equal to 30. We've answered that question 3 times now. But this 3 times F of 40,000, remember, you have to follow order of operations. So this 3 is going to get multiplied against whatever this is. So f of 40,000 is 5. So really this is saying what's 3 times 5? And 3 times 5 is 15. That is not the same as 30, right? So no, these two things are not the same. You get two different values. All right, we're going to do one more from this section. It's another word problem because we love word problems. We see why all this math is useful when we look at word problems. Let me clear this out. I want to do number 60. Number 60, the cost of producing specialty golf hats is given by the function C of x equals 4,000 plus 12x, where x is the number of hats produced. Part A, what is C of 200? And they do ask us to interpret this result. Guys, this question of interpreting the result is so important because it drives home what it is you're finding. It's not just random numbers that we're looking at. There is a rhyme and reason to this problem. And in this case, C is going to be the cost of producing golf hats, whereas X is going to be the number of hats produced. So in part A, C of 200 is going to be equal to, well, whatever plugging 200 into the equation is. So remember your equation is C of x equals 4,000 plus 12x. So C of 200 is going to be equal to 4,000 plus 12 times 200. So I'm plugging 200 in wherever I see an x. When I plug that in, I do get 6,400 if I work it out. So what does that mean? It's going to cost $6,400 to produce 200 hats. All right, part B. What is the cost of producing 250 hats? And they do ask us to write this as a function notation. So they're telling me that C of x equals, nope, let me back up here. I read that wrong. They're telling me that we've got 250 or 2,500 hats. So C of 2,500 equals what? So very same thing as we did last time. I'm just going to plug 2,500 in for x and work it out. So C of 2,500 equals 4,000 plus 12 times 2,500. So C of 2,500, oh, this is part B. C of 2,500, if I work that out, we get 34,000. So that's the answer in function notation. 2,500 hats is going to cost us $34,000. Okay, that's all I've got on functions. Again, as always, if you have any questions on any of this material, if there's anything that you didn't understand as I went over, if you're having problems on the homework, whatever it may be, feel free to get in touch with me.